And let's look at number 2. Y is equal to x over the cube root of x squared plus 4. Okay, so I am going to, of course, rewrite that as x times, divided by, x squared plus 4, and then we would raise that to the 1/3 power. Okay, so I've got a number of students who, for whatever reason, they avoid the quotient rule at all costs. Can you see that I'd have to use the quotient rule on this? I got a function divided by a function. I need a quotient rule. So what they do to avoid the quotient rule is they rewrite it as a product thusly. Y is equal to x times x squared plus 4, and then raise that to the negative 1/3 power, and then use the product rule on it. When you're all done, though, you're still going to have to do the fancy factoring technique so that you can clean it up and make it look sort of like the function that you started with. You know, nice, complete, single fraction, positive exponents, and whatnot. Okay. Regardless, whether we do it like this or like this, when we take the derivative of this component, we will have to use the chain rule because you got a function raised to a function. We're going to do it on this one here using the quotient rule because we already did one with the product rule. Come on, let's vary it up a little bit. Okay, once again, on number 2, it was y is equal to x over x squared plus 4 to the 1/3 power. I'm pretty sure. Okay, let's take its derivative using the quotient rule. Y prime is equal to, the derivative of the top is 1 times the bottom, x squared plus 4, 1/3 power, minus the top, x, times the derivative of the bottom. And here's where the chain rule is going to come in. So when I take the derivative of the denominator, I'll have to leapfrog this power down and then subtract 1 from that power. So it's going to be a 1/3 x squared plus 4. And then subtract 1 from the 1/3 gives me a negative 2/3 power. And it's not done yet, right? Chain rule component, I have to now take the derivative of the interior function here, which is times 2x. Okay, all right then. And don't forget your denominator being squared. X squared plus 4 to the 1/3 squared. So if you're going to square something raised to the 1/3 power, you multiply your exponent, so it's 1/3 times 2, which is 2/3. Yeah? Okay then. So now let's maybe clean up the numerator. Understand this. If it was free response, this is safe stoppable because 100% of the calculus is done. The rest of it is algebra. And we're just getting the practice here, you know, in a multiple choice kind of situation so we can match up our answers. You know how we do. So go ahead and distribute this 1 through the parentheses here. Except don't, because you can't do that. You have to first take the cube root of all this before you can distribute the 1. We know this. X squared plus 4 to the 1/3 power. And then whenever I go to clean this thing up, I'm going to bring this 2x out here with this 1/3 and this x to make this a negative 2/3 x squared. And then x squared plus 4 to the negative 2/3 power. Yep. X squared plus 4, 2/3. I cannot tell you how many times I've seen some students just take this term right here and then just cram it down to the bottom. But you can't do that. And the reason why you can't do that is because it's not a factor across the whole entire top. You can only take a factor down. Like if it's being multiplied out front times this whole quantity, can you take it down? You can't take it down if it's just in one component there, which means it's time for some fancy factoring. So that fancy factoring is going to bring out a factor of x squared plus 4, but specifically to the lowest power, which is at the negative 2/3 here. So bring that thing out. So x squared plus 4, negative 2/3 power. Open up those brackets. And if I do my little strategy here, where I take something to the 1/3 power, and I'm dividing it by that same something to the negative 2/3 power, and I subtract my two exponents, 1/3 minus a negative 2/3 makes it that something to the positive 1, 3/3 power, right? Yes, that is correct. So x squared plus 4 to the first power. Okay. Minus, oh, dang it. You know what I didn't take into consideration? The fact that we have thirds here. Since we have thirds here, I'm going to make a complex fraction. I got to get rid of that. I should have factored out the third, the 1/3, as part of my GCF, even though it's not actually common to both pieces. You know what? I'm going to do it right now. I'm going to pull out that 1/3. So what does that leave for the coefficient of this guy? You know what? There's just not enough room here to put it, so I'm going to move it over just slightly. There we go. It needs to be a 3 because 1/3 times 3 is this 1 that's right there. Of course. Okay. All right, and then for my final factor here, this 2/3 divided by 1/3 is going to leave me with a 2, writing with a laser, 2 x squared, and then this factor is identical to what we pulled out, so it's gone. And then don't forget your denominator. Okay, all right, now let's clean this up by putting fraction stuff, this 3 down at the bottom. This x squared plus 4 to the 2/3 power, it's negative. I'll bring it down to the bottom as well. And then just simplify this here in the parentheses. I've got 3x squared plus a 12, which I'll combine up with a negative 2x squared. All right, here we go. Here's our final answer. Across the top, I have 3x squared minus 2x squared gives me just an x squared plus 12. All of this over, this 3 is going to come down, 3, bwomp, and then parentheses here, I'm going to have x squared plus 4 to what power? Think about this. When this comes down to the bottom, it's going to be positive 2/3 power that I'm going to multiply times this positive 2/3 power. So it's like this. It's like, wait, this needs to be in red. A to the 2/3 times a to the 2/3. Like powers, you add the exponents this time, it's going to be 4/3. And then call it a day. This is a day, not a derivative. No, it's a day. All right. There you go. There is number 2. Why don't we go ahead, since we have time, we've got lots of time. Let's go ahead and try this number 3. So on this number 3, the interior function here is a fraction. It is a rational function that we're raising to the second power. So I can do that general power rule here and leapfrog this power down, but whenever I go to take the derivative of the interior, I will have to use the quotient rule. So do you guys have your head wrapped around that particular question? Do you have it memorized for me so you can call it out to me? All right, excellent. So 3x minus 1, x squared plus 3. Y is equal to 3x minus 1 over x, I don't remember, x squared plus 3. And then it's squared. Okay, chain rule. Why am I having to use the chain rule? Again, I got a function raised to a power. So leapfrog that power down 2 times, a 3x minus 1 over x squared plus 3 to the first power. And now I need to multiply it times the derivative of the interior. And when this gets really complicated, again, the strategy is this. Just write it down. The derivative with respect to x of 3x minus 1 over x squared plus 3. Okay, just as a reminder that that's what you have to do. Okay, let's keep going with this. 3x minus 1 over x squared plus 3 to the first power. I just raised it to the first power. Excellent. So now I'll have to use the quotient rule on this whole entire thing. Derivative of the top is 3 times the bottom, x squared plus 3, minus the top, 3x minus 1 times the derivative of the bottom, 2x, over the denominator squared, x squared plus 3, quantity squared, g. Okay, so whenever I do go to clean this thing up, I'll be able to combine these two denominators here because they're exactly the same. So we do want to fix this right up here by doing some expansion and combining like terms. 3x squared plus 9, and then distribute a negative 2x here, so a negative 6x squared, and then positive 2x. I think. All right. All right, this front stuff, not really affected. I'm going to keep it as it is. Okay, and then in this next set of parentheses, combining up my x squareds, it looks like I got a negative 3 of them, negative 3x squared, and then a positive 2x, and then a positive 9. That's fine. X squared plus 3 quantity squared. And then maybe one more simplification. I can combine these two powers of x squared plus 3 to make one complete one and get something along the lines of 2 times 3x minus 1 times negative 3x squared plus 2x plus 9 all over x squared plus 3 cubed. Okay. And, I would say call it a day, but we called the other one a day, so this one doesn't get called that. They'd be totally confusing if they both had the same name. What am I even talking about? Anyway, now one last thing you could possibly do to this is that maybe you pull out the negative sign here. There's no sense in trying to factor this one unless this denominator goes into that one, which it's not gonna. So I'm going to leave it like that and not call it a day and, just call it the answer.